Welcome class. This video lesson goes with homework 2. The focus, there are quite a few different items in this homework, but the gist is to figure out what numbers divide evenly into other numbers. We saw in the last lesson sometimes there's a remainder, but when the remainder is 0, we say it's divisible by a number. So we're going to talk about some techniques for recognizing divisibility, what factors are, and close with what the least common multiple is. Some terminology just to be familiar with. If you hear someone talk about counting or natural numbers, they mean things like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Notice there's no signed numbers, which we talked about last time, positives and negatives. The phrase whole numbers usually includes all of those plus 0, and then when we use integers, we're including both positive and negatives. But again, these are whole numbers. These aren't decimals or fractions. When we say rational numbers, we mean fractionals, but there are also decimals that aren't rational numbers. We might call all of those numbers together real numbers. So for the most part, what we've been working on in this unit are signed numbers, integers, and we will also deal with fractions. So you'll often notice in the homework it says to write your answer as an integer or fraction. That's meaning don't put a decimal in. Go ahead and put it in one of those two forms. When we talk about the factor of a counting number, we mean all the numbers which divide evenly into that number. So for 12, its two easiest factors are always 1 in itself. And then 2 times 6 is 12, so 2 and 6 are a pair of factors, and 3 times 4 is 12. So we get the factors 1, 2, 3, 4, 6, and 12. 5 doesn't go into 12 evenly, so it's not a factor. 7 doesn't go into 12 evenly, so it's not a factor. And I like to write them out in pairs, and that helps me get all the factors. They don't necessarily need to be written in numerical order. So when you're doing the homework, if you wrote 1, 3, 6, 2, 12, 4, it would still mark it correct. So however you organize your work is fine. Here are just some tips and tricks. Divisible by 2, you can tell by just looking at the last digit. So 1, 4, 3, 2, it's a big number, but it ends in a 2, so it is divisible by 2. Here's a trick you might not be familiar with. A number is divisible by 3 if the sum of its digits is divisible by 3. So for this example we had above, what's 1 plus 4 plus 3 plus 2? 5, 6, 7, 8, 9, 10. And since 3 doesn't go into 10, 3 doesn't divide 1, 5, 4, 3, 2. Just using that technique. You want to know if it's divisible by 4? Divide it by 2. If it's still even, then 4 goes in there. So sometimes if you've already checked if it's divisible by 2, it's easy to see if it's divisible by 4. If it's divisible by 5, the last digit will be 0 or 5. 6 has to be divisible by both 2 and 3. 9 has the same technique as 3. If you add up the digits and they're divisible by 9, then it's divisible by 9. Divisible by 10 ends in a 0. So, and you need to check up through about halfway to get all the pairs of factors. So let's look at the factors of 32. I'm going to start with 1 and 32 because I always have 1 in itself. Since it ends in a 2, I know that 2 is one of the factors, and I'm going to actually do the long division. 2 goes into 3 one time. 2 goes into 12 6 times, so I get 2 and 16. 3 plus 2 is 5. 3 doesn't go into 5, so 3 won't go into 32. So 3 does not work. It's not one of the factors. When I divided by 2, what I got was still even. So that means 4 is going to work. Divide 16 by 2 and I get 8. So 4 and 8 go together. Because it doesn't end in a 0 or a 5. 5 is not a factor. In order to be divisible by 6, 2 and 3 had to work, so 6 isn't a factor. So it just comes down to 7. 7 doesn't have any neat trick. You can do 7. 7 plus 7 is 14. 14 plus 7 is 21. 21 plus 7 is 28. 28 plus 7 is 35. Since we skipped right over 32, 7 doesn't work, and so we found all the factors: 1, 32, 2, 16, 4, and 8. When you do the homework, note that it says to list them separated by a comma, so make sure you do that. The next type of factor we're going to talk about are prime factors. So we need to have a definition of prime. A prime number is a number with exactly two different factors, just one and the number itself. So it can't have any other factors. Some examples are 2, 3, 5, 7, 11, 13. 10 is not prime because 10 is 2 times 5, so it does have other factors. 6 is not prime because 6 is 2 times 3. And in fact, there are infinitely many prime numbers. But on some of the homework, you're going to be asked to list the prime factors, give the prime decomposition. And in that case, it's saying, what prime numbers do I multiply together to get this particular number? And the technique I'm going to use for that is something called a factor tree. Those of you who are familiar with exponents will note that something like 2 times 2 times 2 times 2 times 3 can be written as 2 to the 4th times 3. In this homework 2, where they're not expecting you to know exponents, they're not expecting you to use exponents. So they'll actually want you to write it out in longer format. So I'm going to try breaking 75 into primes. To start, you just have to think of one thing that you know goes into 25, and you can start the tree off differently than your neighbor, but we'll all end up in the same place. I like to think of 75 cents as 3 quarters, so 3 times 25 is 75. 3 itself is prime, so I can stop there, but 25 is not. 25 is 5 times 5, and 5 are prime. And so now I'm done. This is the factor tree, and this says that 75 is 3 times 5 times 5. You'll find this little multiplication symbol down in the math toolbar when you're entering the homework. And in fact, it doesn't matter if you were to write it as 5 times 3 times 5 or 5 times 5 times 3, all of those would be correct. My tree just happened to give me that, but any of those would be fine. The last thing you'll come across in the homework is the least common multiple. This is the smallest number that both 2 and 5 divide into. So it's the smallest number that's a multiple of both 2 and 5. So in that case, 2 and 5, we get 10. And one of the techniques I do is to write out the different multiples. 2 plus 2 is 4. 5 plus 5 is 10. 4 plus 2 is 6. 10 plus 5 is 15. So the top are the multiples of 2 and the bottom are the multiples of 5. 6 plus 2 is 8. 15 plus 5 is 20. 8 plus 2 is 10, and that's our first match. So that's how we get that the least common multiple is 10. So let's try it again with 6 and 8. We got 6 and 8. 6 plus 6 is 12. 8 plus 8 is 16. 12 plus 6 is 18. 16 plus 8 is 24. 18 plus 6 is 24, and we got our first match. So the LCM is 24. Some techniques, if they're both prime, the smallest thing that they're going to go into is literally 3 times 7. If one number is a multiple of the other, so like here 2 and 12, where we know 12 is divisible by 2, then the LCM is actually just going to be 12 itself. So it's possible that the least common multiple is one of the two numbers that you're seeing. And then, as in the case of 6 and 8, sometimes it's something between 8 and 48 where you find it. So somewhere in between if they share common factors. Let's do the LCM of 12 and 15. So we have 12 and 15. 12 plus 12 is 24. 24 plus 12 is 36. 36 plus 12 is 48. I just did a couple. 15 plus 15, 30. 30 plus 15, 45. 45 plus 15, 60. Still haven't found it, so I need to do some more. Add 12 and I get 60. Oh, that was it. Just a little more persistence. So 60 is the LCM. If you have any other questions, or if you want to see how to use the factor tree to find the LCM, you can click Help Me Solve This on the homework. That'll show you how to use a factor tree, or you can contact me and I can show you. Let me know if you have questions. Bye.